check.
Okay, nothing's come up yet.
It'd be great if there was an easier way to check
Yeah.
if it was working.
Whoa, that's
If it was
fancy.
working.
Whoa, that's fancy.
Yep, I think it's working. Sweet.
We
Yeah,
got some fancy text now.
mate, I followed a Photoshop tutorial in the last 20 minutes heading up to going live, so
Nice.
appreciate the Chrome 80s font. There was other
We
things you could... I was going to say, there's other things I could have done, but I ran out of time.
we are becoming pro streamers.
Mate, check out our pro streaming strats. It's to have like stuff with a fancy font.
It's not animated though, so
No,
we've still got some ways to go.
I suppose I could probably follow the same process I did in Photoshop, but in Premiere or After Effects, and actually animate something.
Yeah, it's very retro, isn't it?
That's what I was going for, was that retro feel. I was like thinking of how do you do the VHS kind of haze in Photoshop?
Oh, yeah, okay.
Yeah, I don't know.
That's the next steps.
Just said it looks cool. We'll wait another minute or so before we get started, so people can look upon my wonderful Photoshop work. How are you doing, Jake?
Yeah, I'm pretty good.
That's good. That's good.
It's Monday, start of the week, but doing okay because we're streaming some more reverse engineering.
It's public holiday in Victoria today, so that was quite nice.
Yeah.
It's a bit weird that we have... I wonder if it's the same in like other countries that have states where they have public holidays all on different days.
Do New Zealand have states, or is it like North Island, South Island are kind of...
No,
That's
they have
how
the
it works?
the government, and then like I guess you could call them council areas or shires or like local government. They don't
Oh,
have
okay.
states.
Just regions, okay.
Yeah, there's like Marlborough where my granddad lives, and then Southland I think is one of them. I don't know all of them. Canterbury is
Oh, no,
like where
that's nice.
Christchurch is.
All of them, just curious.
Yeah, I just
Oh,
start
okay,
listing.
so they do have some separate, like public
Ah,
holiday type dates.
good times. Okay, well, we've given everyone a minute or so. Let's just get into it.
Yeah, let's dive in. So this week we're doing DSYM. Sim?
So it occurs to me that we should probably, at some point, switch to doing reversing challenges that aren't exclusive to Hack the Box.
Yes.
Because...
There are a bunch of sites with different reverse engineering challenges, which I took a look at, but I hadn't completed any of them, and they were significantly more difficult than the Hack the Box ones.
Yep, as it is. But this time round, we've both independently done them. We've done this one, this one. We've done it two different ways. So I guess we'll start with the way I did it. Let me just get the right window open. Fire out so many things. And we'll get started. Let me just check that it's all working. And I'll log in with my super secret password. So if you do have access to Hack the Box, it's a retired challenge called come on, be useful. Don't jump around like that. DYSM. It is in the retired section, so we should be fine streaming this. I say we should be fine. We are fine. All right. So when you get started, so I'm going to assume you've extracted it, and you'll get these two files: Don't Know What I Am and Get Me. I've started a Gidra project, which is why that's there. Get to that in a bit. So we start with these two files, and the first thing to do is just to check what they are. Generally, for Hack the Box reversing challenges, they're going to be binaries for whatever platform we're on. So file that one, and let's do Get Me. Files just... It reads magic numbers and headers for a bunch of different file types. So it could, Jake, I'm trusting that you're going to be keeping along with any Twitch comments that come up. Yep, sweet. So both of these are ELF executables. The one interesting thing to note is, and this took me a while to find, and so I'll get to this in a bit. Once I've run through my thought process, but this interpreter empty section here is opposed for the don't know what I am file. versus the my voice keeps popping. Um, versus the interpreter like LD Linux x8664.so. So that's the first interesting thing that comes up. Of course, I didn't notice that right away, so I went through this whole process of I used strace on don't know what I am, and I was like, oh, that does nothing. By the way, strace, so we used ltrace last week, which traces calls to other libraries. strace just traces calls to like system calls, of which there's a whole bunch. I'm trying to remember back to when we were streaming, probably back in 2019 now, but like changing the user ID for the process is like a system call. For example, reading files, creating file handles and stuff like that are all system calls that the C compiler manages, I guess, mapping that stuff through. So we do an strace, we don't get anything, just out of curiosity, an ltrace on the same thing. Gets us a whole bunch of garbage, and then nothing. The thing doesn't actually run without any of that either. It just gives us an exec format error, which mystified me for a little bit because I was like, what, is it a different architecture? Googling around doesn't really help much either. So at this point, I moved on to seeing what the get me does, and it does nothing as well. But this time around, if I was to do an strace, we do get a bunch of stuff. And this is where I guess things started to come together. So what we have, I went down this whole rabbit hole of looking at this like ld.preload business going on here. And I was like, what the heck is that for? And I thought maybe this was something to do with, it looks like back in the day, you used to be able to have an environment variable called ld preload, and you could say, here are all the libraries to preload before you load the actual binary. And you could use this for Seward binaries to get control by loading in your own version of a library that everything uses, libc or something like that. And this ld.preload functionality just checks if it can read or write from a directory in etc. And if it can, you're root, and therefore it'll quite happily load stuff from ld preload, but when you're trying to use it with the Seward bit set, it won't load from the user's path. That, all an aside, not path, the ld preload environment variable. That's what I think it is. That's not what this is about. That was just a random aside that I stumbled across. Maybe something interesting to look at, but it looks like it's been a solved problem for a very long time. However, where we start getting to is, it looks like it's trying to read another file, which has ELF. Actually, that's just at opening libc. That's fine. There's somewhere in here, I'm trying to remember where it is. Maybe it's not in here. There was if we do a strings get me, somewhere in here we see a reference to don't know what I am, and that combined with this up here made me start to think that the get me file was opening the don't know what I am file, which finally led me to googling around and finding out that actually a file, don't know what I am, a file that has this dynamically linked interpreter empty section, or the interpreter empty really, is most likely debug symbols. So when you compile your C code down to machine code, all of your nice pretty names of functions and variables and stuff normally gets lost, which is why when you decompile something, whether it be like Java or C or C++ or Rust, well, maybe not Rust, I don't know much about Rust, you just get decompiler generated variables and function names back, and normally it just either names them based on their memory address or their address inside the binary, or names them just iteratively, so variable 1, variable 2, maybe context.
Yeah, and
so
that's
local
sort of what we see in Ghidra too when it decompiles
Yep.
the app.
But this likely means that this is a debug symbols, which is specifically when you compile something, you say, create another file that contains debug information so that when you run it with a debugger, you get some intelligence, which is then where my next step was. So I did a little bit of research jumping around going, how do you load debug symbols? But then realizing then most of the time it just happens passively. So debuggers tend to be able to go and look at the reference to the debug symbols file. Again, it's something to do with the fact that there's this string in this file somewhere in there. There's an open. Where is it? I swear I remember seeing something that was like, here is the file to open, but I don't know. All good. Anyway, so that's what we're going to do. We're going to go into GDB, which is what does G stand for in GDB? General debugger?
General debug? Sure. It might be like GNU debugger or something.
Oh, probably me. Probably. So GDB jumps us in, and we're really... half a sec, let me just get to the bit so I know what I'm talking about, which is always important. So what we're really doing is... So let me get my thoughts together. When we open up GDB, it's got the binary loaded, ready to go, but it actually hasn't started execution yet. So we're kind of in the state that we can analyze it. So if you do this before you actually run it, you go info functions.
It is GNU, yeah, okay.
Yeah, that makes sense. They, gotta keep the Free Software Foundation happy. So what we get, and it's when you run this before you actually run the code, you get a smaller set of results. It only looks at the debug symbols or references from the file. So originally, this was in a file called getme.c. That was what the source code was in. We don't have a copy of that. But on line 25, they had the main function defined, and on line 8, they had the not me function defined. It's interesting that that's there, but at the same time, obviously not 100% sure what's going on. We can try and do a disassemble, I think that's how you spell it. Disassemble, that'll do. Disassemble main. And it doesn't seem to be doing much. My reading assembler off the top of my head's not great, but we're doing something with the stack up here. We're moving a value around. So the stack pointer, base pointer, that's right. Yeah, that's just your normal starting stuff in a function. We're moving the value of 0 into EAX, and then we're popping the base pointer again, which just really looks like... And I'm thinking ahead knowing what this looks like when you decompile it, but effectively all this is returning 0. It's doing nothing. So which means probably the function we want is this one to run, and it's not going to ever run. Assuming looking at the disassembly. We can just hit run, and it'll run it, and then if I go info functions, info functions, if we go info functions, we get a hell of a lot more data because now it's run. Actually, no, there's not as much as I... Oh, there is a bit more. Oh, no, there's tons more. That's right. You got to hit C. So if we...
Yeah, there's a buttload of calls and files and functions.
If you run info... Oh, I heard a fancy sound.
Oh, we just got hosted. Thanks.
Oh, sweet. Cheers. So if you hit C, it'll spit everything out. But if you run info functions before you actually run it, it'll only tell you what's in the particular binary you've got open. If you run it and hit run and then actually run info functions, you get every single thing that was loaded into memory. So that's why I did it beforehand. Originally, when I did it afterwards, and it was a bit of a mess. Just for reference sake, let's go and have a look at the not me function. And let's just hit C to continue. Let me just make this a bit bigger. There's like a bunch more going on in here. This is probably the function that we want to run. Normal functiony stuff up here. Sorting out the stack. And then just a whole bunch of move, I think long is the L. It's basically just moving a whole bunch of values into the stack because we're referencing off the base pointer. Again, my reading assembler is not particularly great. Load effective address is this weird thing in x86 where it's sometimes used for addition and sometimes used for actually loading functions. But anyway, it does stuff. So let's exit this and let's jump over to the way I solved the problem. So knowing that we need to hijack the flow of the code, we can do something that we did last week, but we didn't do a great job of last week.
Yeah. Which is mostly Gidra's fault, to be fair.
Yeah. And I ran into this same problem when I was doing... Oh, no, I don't want to create a new project. When I was doing this during the week. So we want to load up get me. So folder import. We do want to go raw binary. Even though they said they fixed the issue, you still can't dump out patched binaries and have them work.
Yeah.
We want to go GCC for x86. And OK. And actually, just because we want to be able to reference the actual file, we're going to import the same file again. I'm going to call this get me reference. And we are going to let it use the format. Get me reference, the way we're going to do this is I'm going to open up get me reference. I guess if you can follow along, feel free. Let's analyze. Let's just hit select all. Sometimes it couldn't do a couple of them, but seems fine. So you'll notice though that we don't get the nice debug symbol. So the actual function we're after from memory, 1145. This looks a lot like the GDB output. And here's what it looks like as C code. What's interesting is, so 0x16 is the value 21, knowing that loops start from 0, local C set to 0, I should say, not loops start from 0. This will run 22 times over this local 68 variable, which only has 4 values. So I'm wondering if there's, Gidra's decompilation's weird. I don't know. But anyway, this looks a lot like what we were looking at before. These might just get stuff on the stack because all you're doing is you're creating them with their values, and then there's some business going on here. I don't know. But this is the function we want to run. The way I actually found that was by literally starting up here and hitting the arrow through every single function. That's just purely because I'm not a Gidra power user. I'm not even a Gidra beginner user. I know how to do the basics, and that's it. Not even the basics, probably. Anyway, so we want to go back to entry, which is the starting point that Gidra detects. I'm pretty sure it knows where the program would actually start running from. That's the assumption I'm going to make. We can see in our C-ified version of it, I guess, we've got this libc start main, which goes and says, grab this function, which is likely the main function that we were looking at before, and given it's just returning 0, that's probably what it is. There's no buffer overflows here, there's no other funny business, there's literally just hijacking the control flow. And so that's all we're going to do. In theory here, in this call here at line 107D, we could change it here, but when we've imported it and kind of defined the format like we did, you can't export patched binaries. So all I'm going to do is remember my line reference, which is 107D is the line I'm looking for. And we'll just don't save. And then we'll open up the raw one. And yeah, let's analyze. Probably don't need to, but we could. And we're going to go down to, where's 107? It's probably nicer ways to do this, but 107D. This looks kind of similar to what we were looking at before, but because we imported a raw, it doesn't have as much knowledge about exactly what's going on. I'm assuming when you import the actual formats, it goes and figures out, right, that's opening this library, that's the function name from this library. Whereas
There's
here,
probably a way to do it when you import it raw, but we
yeah.
just haven't figured out what that is.
So we don't see anything about the entry point or anything like that. However, knowing that without modification, it's running the main function, but if you run 1258, it's going to be the main function. So if we have a brief squiz at 1258, yep, that's the main function. So if I go back to, oh gosh, again, there's probably much nicer ways of doing this other than watching me scroll around. Right, okay, so all we're going to do is we're just going to go patch instruction. And then we just wait for it to do its thing. And the address we want is just 1145, which we knew from the version we were looking at before, that it was the function at address 1145 was the one we actually want to run. Now that that's modified, I can just probably open that up, and that's fine. Yep, and that looks a lot like our thing from before, just with some of the variable... Actually, no, most of the variable names are the same.
It's mostly the same there, yeah.
Yeah. And then, just to check that nothing's broken, just to... Yeah, 1145. Cool. And we're just going to go export program. I'm going to call this get me patched. And select output file. And OK. And OK. And now what we should have is get me patched. And let's make that executable by 775 get me patched. And just to double check, it's nice and green now. That's thanks to ZSH. And we give it a run. And that text looks similar to what we have. If I go back to here, we go down to here. Actually, no, because it'll be a memory address. It's actually this function here. But if I don't save, just for reference, I don't know why I closed this. Oh well. Video functions, and then back to here. Yeah. So the function here, you almost got me. Here is a small price for you. And then what we get is this. So that string, I went into way too much effort when I was doing this, trying to go, wait a second, because the function's called not me, and it's probably just a reference to try and get you to go, maybe that's the function I want to run. But here I am thinking, well, this is like a bitwise XOR. So, it compares two values one by one, so each bit, and if both bits are the same, you get a 0. If both bits are same, whether they're zeros or ones, you get a 0. If they're each different, you get a 1. And so if you have your original variable or original data as binary and all zeros, you generally get the same thing out. It's how you can mask to get specific bits from a bit of data and stuff like that. There's all sorts of stuff. So I thought maybe you had to fart around with that value to get the right key out, because this isn't the format the flag's meant to be in. It's meant to be in this, you can see it here, this, actually, let me get rid of that, HTTP some text kind of format. So what we're going to do now is we're going to go to, let me find the website,
Crypty.
Crypty.com, because step 1 is going to be... Actually, no, step 1 is going to be...
Yeah, that's fine. You put the ciphertext in.
We've got to add in bytes first, don't we?
Yeah, but you can change it anyway. Yeah. It doesn't matter.
That's what I did. So go back to here, because this is just... I thought it was way more complicated than it really was. And that is to say, we dump this in, and this gives us this value, and bit of thinking later, and we started to do this manually, and then Jake threw this together because it makes a lot more sense. Um, Only the alphabetic characters have been shifted, and they've been shifted by a value of 13, which is ROT 13. And it doesn't matter if it's capital or lowercase. Capitals stay capitals, lowercase stay lowercase, but what we get is "you really got me." And if you notice, all the symbols and the numbers stay the same.
But this side is good because it's got a bunch of different options, and you can kind of chain the decoding and things like that. So you can change like the shifts and the ciphers, and you can do like visionaire decoding and all that kind of stuff too. So it's a good handy tool for if you've got a piece of ciphertext that you know there must be some way of reversing it, and you just got to figure out the pattern to
That
put in
time
there.
it gave me an error. Maybe it's because I've already submitted the flag.
Is it because you've already submitted it? Maybe?
Yeah, I would say I already submitted the flag.
Yeah.
Trust me, that's the correct flag. So this is kind of like I guess you could say, the static analysis approach to this. There were comments from people in the forums for this particular challenge where they did it completely without actually ever running anything. So I'm guessing that bitwise operation over here in Ghidra, they scripted up or something like that.
I mean, you could probably Python script the reverse of that to get the output or something. Yeah.
Yeah. So I guess you could say this is a bit of static.
Not even the reverse. You could just turn that into some Python that prints out the same hex characters, because that's essentially all it's doing.
Yeah. And I guess you could say this is a bit of static analysis in terms of looking at the code, figuring out what's doing it where, changing the one value we need to change, and patching the binary, which is pretty cool. So next step is the way Jake did it.
Yeah. So this is more of a dynamic way of doing it. So we're going to be doing it during runtime, and basically changing the code execution flow to just call that function directly at runtime, rather than patch the file and rerun it.
So the starting point is pretty similar to when I was mucking around in GDB.
Yeah, so we're basically jumping straight into GDB again, and this time you can see that at the top there it says that it's automatically loaded the symbols from the don't know what I am file.
Yes.
And we do almost the same steps, really. So we call the info on the functions, and we see that there's two functions there. When we just run the app, we notice that nothing happens. Like, it obviously just quits itself, and doing the previous steps of the L trace, S trace, all that kind of thing, we kind of confirm that the main function doesn't actually do anything. So when we do this info functions and we see a not me function, and we know that it's a CTF challenge, we kind of assume that what we have to do is make it execute that not me function.
Yeah.
So the way that we do that is with the command info address not me, and what this will do is it will we'll break on main. Have you already done that?
No, I've just gone. I'll go break main.
Yeah, so you have to actually be running the app, because it hasn't loaded that stuff into memory yet, so it doesn't know where in memory the not me function is. So we break on main, and then we type run just to run the app, and then it'll hit that breakpoint that we've set.
And then we go address.
And now we can do info address not me, and this is going to tell us where in memory that function is sitting.
Yep, it's interesting that it's all fives and then a 145, and then up here where it's just referencing the location in the binary is 1145.
Yeah.
So they're all kind of related, I guess.
Yeah, and that's kind of how Ghidra decompiles it, I think. Is based on all those references and memory addresses and stuff. Because there's no ASLR or any of that kind of protection on these binaries, which is nice for us.
So I'm guessing now what we're going to try and do while we've braked in the main function, there'll be the instruction pointer, which is trying to figure out where to go next. And all we have to do, I'm going to make the leap and also look at the notes. All we have to do is just tell the instruction pointer where to go.
Yeah, so basically we get GDB to change the RIP register because it's a 64-bit app. It's the RIP, not the EIP, which is basically the instruction pointer which tells the app go to this memory address next. And so what we do is we set that value to the memory address of the not me function, and then we could tell GDB to break again on not me, or we can just press C to continue running the app.
Yep.
And we see there that what we've done is change the execution flow. So now we're calling that function and we get the printout of the same hex value.
So
And from
effectively,
here, we pretty much follow the same steps to decode it back into the raw flag.
so it's pretty straightforward, but effectively, I modified the stack by going into the. Effectively, you could say the. I almost want to say like it's machine code. It's not source code, but like the machine code and just outright changing the value. One of the challenges with patching machine code is you kind of think most of the time to keep all the references in place, you basically have to be byte for byte perfect. So if you were trying to change an instruction that needed 3 bytes with one that needs 2 bytes, I think you can kind of do that if you knock out the extra byte.
Well, we saw that a bit last week where we had to add those couple of extra knocks to make the code still work.
But it gets harder going the other way. You can't take one that needs 3 bytes and replace it with one that needs 4, because now everything gets shifted. And I'm sure there's like ways to do that run through the rest of the code and try and shift all the references. But if you were sitting there with a hex editor, you could hex edit this. If you knew the right line and
if you knew exactly where to go and what bytes to change,
yeah, which is all we did, except Ghidra helps us.
It's essentially what Ghidra's doing, but it's just making it more human readable.
And your particular method is, instead of that, during runtime, we just outright change a pointer, which we've done before, I think, in EDB in some of our older streams, that it may be floating on YouTube as well.
We've done a couple of times, but it's still not very fresh in our minds.
No, we are still very much getting, after a year of not doing anything, even just like presenting, I'm just like, wait, my brain's going everywhere. I need to like think of what we're doing.
Yeah.
Cool.
And that's kind of it, really.
Yeah.
We essentially did the same thing 2 different ways, statically and dynamically, as in looking at the raw code and then doing it during runtime.
Yeah. And debugging symbols this is why, and there has been a few issues over the years where I think there's been like problems where developers have shipped code, so whether like binary form for various pieces of software that has the debug symbols still enabled within the code. Or I think some languages incorporate the debug symbols directly in the code. Other languages, like C with GCC, it's a separate file. But debug symbols can allow someone to figure out how your code runs. In a lot of cases, if you've coded properly, shipping with debug symbols shouldn't be a problem, because it's not really going to be an issue. You know, if someone knows the names of your functions and variables and where they are, but you don't have buffer overflows or the myriad of other problems that can exist. This sort of thing, you can't do much about someone just editing and completely cutting out code. I mean, I reverse engineered the Sydney Trains app back in the day so that it wouldn't do a root check on my phone, or that the root check would pass, and all you had to do was knock out a couple of lines and it'd be fine. You can't really do much about that, but not having the debug symbols makes it that much harder.
Yeah, and there are like libraries and things like that to add, and we saw this last week. I think there's like anti-debug libraries and things like that to prevent you from trying to attach a debugger like GDB to the apps at runtime, and that's where it's easier to just disassemble it and, like you said, knock stuff out or just completely change execution flow.
As I found when I was doing this through the week, just having the debug symbols file there, and I'm like going, is this packed? Why isn't this running? And then like, finally I pay attention to that output from the File. I pay attention to that output from the. I just accidentally full screened the Twitch thing, and the audio started.
Oh no.
Let me go over here. File. Yeah, like it was just purely because I wasn't. Oh, gosh, no. Wait a second. I'm still in GDB. File. Don't know what I am. Yeah, like, and it was all because I missed this line here. It wasn't until I went back and looked. So always read carefully. Don't just look at this first bit and go, "Oh yeah, that's an ELF for x86." It's not ARM or anything like that. Yeah. So actually, let me just start to get out of here. So yeah, it's kind of it for this week. Not as...
Yeah, that was a really quick one, actually. Next week, we'll probably do a more involved one. There's another write-up that we've got from a couple of years ago for a challenge called Crack This, which is a Windows binary. So we'll do a bunch of different debugging and decompiling and stuff like that in a Windows binary rather than a Linux binary.
And Windows stuff is always more complicated than Linux stuff. Like, basic Linux stuff, once you understand Linux is actually really, really straightforward. Yeah, that was the other thing that AZ Kiwi just mentioned. The fact that strict. It said it was... Yeah, the Dunno said it wasn't stripped. So that was one of the other things I learned in all the research. The number of browser tabs I had open by the time I was done. And this is the joy in these things. I mean, it only took me an evening to figure out, but the amount of other stuff you learn when you just get back into it. And I ended up learning about that LD preload thing. You end up learning about how... I was thinking I had to tell GDB... I looked trying to use EDB and Ghidra to go, how do I load debug symbols? It turns out Ghidra is just a decompiler, so it doesn't load the debug. Maybe there's a way to get it to load debug symbols, but I couldn't find a way to do it. EDB and GDB EDB and GDB just do it automatically. So it's nice and simple. So you learn a whole bunch of stuff as you try and tackle these problems, and then that ends up knocking around your head. Reverse engineering can be fun. It can be pretty frustrating, especially the last bit. And I'm like, how do you what's the next step with that random hex string you get? I was like, what the hell do you do with that? And I was there trying to do all this fancy stuff, and Jake was like, just run it through a hex decoder. And
it's probably just hex, yeah, just decode.
I was like, you bastard. You absolute bastard. So yeah, so that was that. So nice short one this week. We can all kind of go to bed early. I say for you it's what, 7:37?
Yeah, it's 7:30 for me, but for Kiwi it's 10:30.
Yep, and it's 8:30 for me down in Melbourne town, which is funny because I'm further west than Sydney. Anyway, that was that. So we'll be on next week, streaming as usual.
Thanks for coming.
Bear with us as we still get better at doing this. There was a point where I thought we were good, but there's a whole lot of getting used to the flow, not talking over each other, which takes a bit to get used to. Even just keeping the train of thought rather than it just scattering all over the place.
Yeah.
So have a good one, guys.
Thanks, Kiwi.
Stay safe.
We'll see you later.
Tuning in. This will be on YouTube as well. I'll stick the link somewhere.
And our write-up is clean enough to actually put somewhere, so we'll put that up as well.
Yeah. Quick YouTube link. We don't have enough subscribers on YouTube to have a nice URL. We've just got the YouTube default one, but that's where all our streams go. Morky snuck in. Cheers, guys. Stay safe.
See ya.